Welcome to physics, the branch of science that basically asks, how does the universe actually work? Physics is all about laws, not the courtroom kind, but the kind that govern everything, from the motion of planets to the way your phone battery dies way too fast. It all started with ancient thinkers wondering why stuff falls down. But then came Isaac Newton, who saw an apple fall and decided, hey, maybe the same thing pulling this apple to Earth also holds the moon in orbit. Boom! Gravity. Physics splits into two main zones. Classical physics, big stuff you can see, cars, cannonballs, planets, roller coasters. Modern physics, tiny or weird stuff like atoms, light, black holes, and particles that can exist in two places at once. Newton gave us the basics: force, motion, mass, acceleration. But centuries later, Einstein showed us time and space were flexible, bendable like cosmic rubber sheets. That's relativity, the reason GPS has to correct for time differences or it'd send you to the wrong coffee shop. Then there's the bizarre world of quantum physics, where particles behave like ghosts and probabilities. You can't even say where something is until you look at it. It's like hide and seek with subatomic gremlins. And thermodynamics, that's the study of heat, energy, and why your coffee gets cold if you talk too long. Altogether, physics is like the source code of the universe, and we've only hacked a tiny piece of it. Chemistry is the part that builds the universe's ingredients list. Chemistry asks, what is everything made of? And how do those things interact, combine, explode, or dissolve in soda? It all starts with atoms, tiny particles made of protons, neutrons, and electrons. They're like Lego blocks for reality. Combine them in the right ways and you get everything from water to fireworks to your favorite snacks. Chemists study elements like hydrogen, oxygen, carbon, and how they bond to make compounds. Add hydrogen to oxygen, and boom, water. Add carbon to hydrogen in different ways, and you get gasoline, sugar, or plastic. One of the most powerful tools in chemistry is the periodic table, a big, colorful chart that's basically the ultimate cheat sheet for how the universe is built. Chemistry explains why metal rusts, why soap works, why fire burns, and why Mentos in cola causes a soda volcano. It also dives into reactions, when molecules change partners, break up, or go full-on explosive. Some release energy, like fire. Others absorb energy, like instant ice packs. There's organic chemistry, which deals with carbon-based life stuff, proteins, DNA, medicine, even food flavors. And inorganic chemistry, the non-living side, metals, rocks, acids, weird glowing solutions in science labs. In short, chemistry is the science of stuff, and it's everywhere. In your kitchen, in your body, in your shampoo, in the phone you're probably holding right now. Then come biology. Biology asks the big question, what is life? How do living things grow, evolve, survive, or just keep being alive? It starts at the smallest level, cells. Every living thing from a bacterium to Beyoncé is made of cells. Some creatures are just one cell. Others, like you, are made of 37 trillion. Cells are little self-sustaining machines. They eat, poop, breathe, reproduce, and call the shots for your entire body. Inside them, nucleus equals brain. Mitochondria equals power plant, ribosomes equals protein chefs. Biology splits into branches like botany, plants, how they photosynthesize, grow toward light, and sometimes eat flies. Zoology, animals, from insects with compound eyes to whales with heartbeats as slow as a drumbeat. Microbiology, the invisible life, bacteria, viruses, fungi. Tiny stuff, big impact. Then comes genetics, the instruction manual for life. DNA is the four-letter code, A, T, C, G, that builds every organism. Genes decide your eye color, your height, and maybe even your taste in pizza. Evolution? That's biology's long-term game. Natural selection helps living things adapt and survive. Like giraffes with longer necks reaching more leaves equals more babies equals more long-necked giraffes. Ecology looks at how living things interact. Predators chasing prey, bees pollinating flowers, humans accidentally messing everything up. And don't forget human biology. Organs, digestion, your immune system fighting off the flu with white blood cell warriors like, not today. So whether it's studying the brain, the rainforest, or the mold on bread, biology is the science of life itself. Take a step outside. Feel the ground under your feet. That's Earth science. The study of the only planet we, so far, know has tacos. Earth science is a combo pack. Geology, meteorology, oceanography, and environmental science, all working together to explain how our planet ticks. Start with geology, the study of rocks. Not just look at this cool rock, but this rock is 3 billion years old and used to be at the bottom of an ocean. Earth has layers and like a cake, but molten and deadly. Crust, where we live. Mantle, super hot peanut butter. Outer core, liquid metal. Inner core, solid iron, hotter than the sun's surface. Plate tectonics explains earthquakes and volcanoes. Earth's surface isn't still. It's puzzle pieces constantly grinding and colliding. India literally slammed into Asia and made the Himalayas. Yep, Mount Everest is a scar. Now look up. That's meteorology, the science of weather. It asks, why is it raining? Why is it hot? Why is there a tornado warning during your beach day? Air pressure, temperature, and water vapor combine like ingredients in a chaotic soup called the atmosphere. Add a little global warming, and things get spicy. Oceanography dives into the deep. The oceans cover 71% of Earth, hold 97% of its water, and contain things we've never even discovered. Currents control climate. Coral reefs house millions of species. And the deep ocean? Still more mapped than your uncle's basement. Finally, environmental science asks, how are humans messing up the planet? And can we stop before we cook ourselves? From pollution to deforestation to climate change, Earth science doesn't just study the planet, it protects it, because there's no planet B. Next, computer science. Computer science isn't just about building robots or fixing your grandma's Wi-Fi. It's the science of how computers think, how data flows, and how logic rules digital worlds. At its core, computer science is problem solving with precision. Want to tell a computer what to do? You have to be very, very specific. Like, take input A, multiply it by B. If the answer is bigger than C, do X. Otherwise, do Y. That's called an algorithm. Not just a buzzword, but a step-by-step recipe for solving problems. Baking cookies? That's an algorithm. Sorting your emails? Algorithm. Suggesting videos at 2 a.m.? Definitely algorithm. Then there's programming languages. Not English or French, but Python, JavaScript, C++, and more. Each one speaks to computers differently. Python, simple and friendly. C++, fast but picky. JavaScript runs the internet. Kind of chaotic. Code is like poetry, if poetry crashed when you forget a semicolon. Let's zoom out to hardware versus software. Hardware equals the physical stuff. Chips, screens, keyboards. Software equals the invisible instructions that tell the hardware what to do. Ever heard of binary? It's the deepest layer. Computers speak only in ones and zeros. Yes equals 1. No equals 0. That's it. All of the internet, cat videos, maps, video games, made of tiny flickers of yes and no. Magic? Nope. Just logic gates, transistors, and electricity. Doing math at light speed. Now we've got artificial intelligence, teaching machines to learn. AI doesn't think like a human, yet. But it can play chess, write poems, recommend music. Computer science isn't just screens and code. It's the language behind every app, website, robot, game, and future invention you can imagine. And it all started with humans asking, can we teach a rock to think? If science is the engine, math is the blueprint. It's not just about numbers, and it's the logic that makes the universe tick. From ancient times, humans used math to count goats, measure land, and build pyramids. I have 3 goats. You have 4 goats? Now we fight. But math quickly grew beyond counting. Enter geometry, the art of shapes, angles, and ancient Greek flexing. Euclid said, give me a straight line and I'll give you a theorem. Pythagoras said, a squared plus b squared equals c squared, unless c is imaginary. Then came algebra, math's version of hide and seek. X is missing. Go find it. It sounds like torture, until you realize algebra is behind banking apps, 3D animation, and launching rockets. And we can't forget calculus, invented by Newton and Leibniz at the same time. Awkward. It's math for things that move and change, like speeding cars, growing bacteria, or stock market chaos. It asks, how fast is this going? And how much will there be? And then actually answers. Ever heard of probability and statistics? That's math trying to predict the future. Will it rain? What are the odds of winning the lottery? Spoiler, not great, please don't. And then there's pure math, the deep, mind-bending stuff. Prime numbers that go on forever, fractals that repeat endlessly. Weird shapes with infinite surface area and 0 volume. Mathematicians live for this. They scream when a new theorem is proven. Here's the twist. Math is the same everywhere. A triangle in Tokyo has the same angles as one in Timbuktu. The equation for gravity works on Earth, Mars, and wherever Elon Musk is going next. That's why we call it the universal language. No matter